Yo, what's up, class? Well, this is my first opportunity to actually record one of my lectures via slideshow. So here it is. Here it goes. You have to hear my voice and listen to this. This lecture is about primate comparative anatomy. So basically today we're going to be talking about locomotion. And I wanted to give you guys this work to do over the weekend so we can do a locomotion assignment in class on Monday and Tuesday. But first and foremost, we need to talk about a comparative anatomy and behavior assignment. This will not be due March 14th, it'll be due in May, but it is a two-page essay that will be covered, that the material will be covered this week and next week. So I'll upload this question onto the website and refer to chapters 8 and 9 and lectures 8 and 9 and a tiny bit of 10. But these things are likely to appear on the exam. So first and foremost, we're going back to this slide about primate phylogeny. So we have the primate line, and we see we are part of the Haplorhines line, the dry-nosed primates. And the Prosimi are still the wet-nosed primates, considered the most primitive primates. So because this lecture is all about forms of locomotion, that's what we're going to be talking about. So we have slow quadrupedal climbing locomotion, vertical clinging and leaping, arboreal and terrestrial quadrupedalism, semi-brachiation, brachiation, knuckle walking, and then finally bipedalism, walking upright. We're going to say bipedalism for the end of the week, and we're going to work on that together in class. So, why, you may be asking, am I showing a horse skeleton? This isn't a primate, but it gives you an idea of a specialized skeleton. When we talked about generalized and specialized traits, a horse skeleton is specialized for running and walking and trotting on all fours. So the whole design and makeup of the skeletal system of a horse is designed for what a horse does: gallops, runs, and trots on all four legs. Whereas a primate skeleton is considered a generalized skeleton. So it can have a myriad of ways of movement. But this is obviously a quadrupedal primate, so it's using all four legs to move on. But it can still swing from trees and jump and do all the different things that us special primates can use. This leads us to the idea of the intermembral index. So when I talk about the intermembral index, we're basically being able to figure out a way of measuring bones, bone length, and the length of limbs to see what the primates are actually doing, what modes of transportation they're using. So to do this, we use a simple mathematical term, and I hate mathematicals. I hate mathematical functions, but this basically gives us an idea of how that primate is going to move. So we add the humerus plus the radius, and we divide it by the femur plus the tibia, and we multiply it by 100. So the hind limbs versus the forelimbs. So whatever is longer is going to be the part that does the most of the work. So your hind limbs are obviously your legs, and your forelimbs are obviously your arms. If, in our case, we have longer hind limbs. Our legs are a lot longer than our forelimbs. Our hind legs are obviously a lot longer than our forelimbs, so they do most of the work. Whereas if you look at other primates, if they're spending most of their time swinging from branch to branch, their arms are going to be longer than their hind limbs. So bipeds and vertical clinging and leaping, they have the hind limb longer than the forelimb. Quadrupeds, if they're walking on all fours, they're going to be equal length because they're using their hind limbs and forelimbs the same amount. And brachiators, they're using their forelimbs more, so they are longer than their hind limbs. Slow quadrupedal climbing. These are the lorises of Southeast Asia. They use all four legs to climb in branches. They have mobile ankles, wrists, and hips, and short tails. Vertical clinging and leaping, prosimins. They have a vertical body, which is known as orthograde posture. They push off the branch with their hind limbs, so they use their hind limbs more than their forelimbs, so they have longer hind limbs. They're able to turn in midair and land vertically. This is an example that you guys can check out on YouTube of lemur locomotion. So, these are some of the skeletal features that you need to note as you do our in-class activity that we're going to be working on. Your body position, your spine shape, the length and shape of your trunk, the position of the shoulder blade, limb length, finger length, and length of tail. All right, arboreal quadrupeds. This is walking in trees on all fours. So they're able to run and leap in the trees. They walk on their palms on top of branches, so they use their palms and fingers to grab onto the branches. They push off with their hind limbs when they're jumping. They have long tails, and the reason for this is for balance. It is necessary for animals that are balancing themselves in trees to have long tails to keep that balance. They have pronograde posture, which means horizontal posture to the ground. Long fingers and toes to grab onto branches. And then this is where the idea of prehensile tails come in. These are only found in New World monkeys. Now, when I say New World monkeys, I mean monkeys that are found in the Americas. They consider the Americas the New World, as opposed to Europe and Asia and Africa, which is considered Old World monkeys. There are no terrestrial species in New World monkeys. So no species that walk on the ground of monkeys in the New World. Here's a YouTube video about monkeys. All right, semi-brachiation, New World. They use their hands and their prehensile tails to grab onto branches to swing. In the Old World, they use hands and no tails. Terrestrial quadrupeds. These are primates that are walking on all fours on the ground. They spend a lot of time on the ground, but a little bit of time in the trees as well. They have pronograde posture, so they're horizontal posture to the ground. They walk on their palms and toes, so they have shorter digits. They don't need to grab onto those branches like arboreal quadrupeds. They move limbs in a limited plane. They rarely hang full weight on their arms. They have a shorter tail because they do not need that tail in order to balance as they're moving on the ground. They have a barrel-shaped ribcage. And here's a video of a mandrill. All right, brachiation, gibbons. True brachiators have a shoulder on the back rather on the top of the torso. Now the purpose for this is that if it sits on the back instead of the top of the torso, it gives the arm a full range of motion. So we have a macaque on the left here, and you can see how that shoulder blade is sitting there on the back rather than on top of the torso like our shoulder blade. And that gives the full range of motion. They have a cone-shaped ribcage in order to have that full range of motion instead of the barrel-shaped ribcage that we saw from the terrestrial quadrupeds. They have long curved fingers because they need those long curved fingers in order to grab onto branches to have that power grip. And power grips go along with smaller thumbs. So they don't have that precision grip that we have. Our thumbs are used to basically be able to manipulate objects, whereas these power-gripped primate species have smaller thumbs and longer fingers because they need to have that power to hold onto a branch as they're swinging from area to area. Obviously, they have long arms because they're using their arms the most, ball and socket wrists, and no tail. Here's a gibbon brachiating. All right, slow quadronymous climbing, orangutans. They grasp branches with hands and feet and slowly move through trees. Females are almost totally arboreal, so they live in the trees most of the time. Males travel distances on the ground. They fist walk rather than on their knuckles. They had a brachiating ancestor. We know this because they have longer arms than legs. They have a cone-shaped torso as well, so they have that full range of motion. No tail and long fingers. Here is a video of orangutans. All right, knuckle walking. Chimps and gorillas. So great apes, too large to brachiate frequently. So these great apes don't spend too much time in the trees. They spend most of their time on the ground. They still use their upper body and arms to suspend when they do. They have stronger wrist bones than brachiators in order to support their weight on their arms as they move on the ground. We also know they came from brachiating ancestors because they have long arms, longer fingers, no tails. The scapula still sits on the back, and they have that cone-shaped torso. So that is the end of a lecture today. We will work on bipedalism in the next following days. If you have any questions, please email me and let me know. Thank you.